Hello out there, welcome back once again. We are looking at correlation in data, okay? So remember, your pen and paper, you work hard. It's okay to be challenged when you do mathematics, but what is important is continuous hard work. Even if though you don't understand anything, you keep working hard every day. I mean, you don't wait for a challenge to start doing your mathematics, okay? I can promise you, continuously, if you can do an hour, you won't see those challenges. Because most of our challenges, what we try to do, 2 days before a test or a big exam, we want to cram everything. That's impossible. You have to work on continuous basis. Okay. So let's see what we have under correlation. So now we said we'll focus on correlation. And we did define what is correlation again. Remember correlation, we talk about association between two variables in this context. I give an example of what? Oil price and petrol. Those two there's a strong association between those two variables. Okay. Usually if petrol price goes down, it's because of the oil price. Are we all together? Something of that nature. So think of other variables that are associated, meaning correlated or with correlation. Okay. So let's see what we have now. So we can use a scatter plot to show whether there is an association or correlation. I've used the word association and correlation, interchanging the two means exactly the same thing. Association, associated, correlations, just exactly the same thing. And remember, what is a scatter plot? Okay? A scatter plot, if I take my Cartesian plane in the first quadrant and I put all the coordinates, okay, my dependent and independent variable, that is my scatter plot, okay? We'll look at an example at a later stage. So let's see what we have. So if points on a scatter plot, so we're talking about points. When we talk about points, we're talking about independent and dependent variable. So it's the coordinate, which is x, y, okay? So we put those coordinates, we kind of have a table. And we put all our coordinates, okay? And if you look at the trend, we can kind of guess our correlation. Okay, let's see. See, if the points on a scatter plot are roughly in a straight line, we say the variables are correlated, So let's see what is that. So something like this. So there we have our points. You can see our points there. But if we draw a straight line, which we have there, our points are scattered close to the straight line. Are we together? So we say now there's a strong association between the x and y. And remember, x could be anything. It could be petrol price, and this could be the oil price. Okay? This is independent variable, and that is our dependent variable. Strong positive, and very important, why do we say positive correlation? It's a strong positive correlation. Okay, I'll come back to that. The strong positive correlation. So when we talk about positive, if you look at the straight line, you know, the equation of a straight line, you can think of something like that, which is y equals to mx plus c. If you remember that. So m is the slope or the gradient, okay? This does not mean this is the equivalent line. Just give you an example. So if the gradient is positive, your line is going up. If m is bigger than 0, positive, that's if m is positive. And if m is smaller than 0, which is negative, your line is going down. So we say positive correlation going up. What does positive correlation mean? Implies the independent variable and dependent variable, they move up together or down together. That makes sense? If oil price goes up, petrol price goes up. Are we together? Another way we can think of positive correlation, the more hours I do my maths marks, I increase my hours, my results go up. Positive correlation. Are we together? Are we together? Can we think of something with negative correlation? One goes up, one goes down. Have you heard of something called inflation? If inflation goes up, the value of the money goes down. So those are negative correlated. Okay. So this is a positive correlation. So let's look at a weak positive correlation. So the points are more scattered but follow a general upwards trend. So let's look at that. So there it is. I mean, yes, the points are not scattered like compared to the first one, close to the line, but yeah, they're roughly scattered around the line. So we said this is a weak positive correlation. What does a weak positive correlation mean? Can you think of something? I'll say, you know, the more hours I sleep, will my maths marks improve? Versus the more hours I study, my marks will improve. More hours I study my maths, marks will improve. There is an association. But the more I sleep, will my marks improve? There is an association, but which is stronger? The strongest, I think, is the more I study, the more I will perform better. Because I could sleep, but not doing my maths. Doesn't mean it's associated. So it's weak correlation. But also, I can't study so many hours and not sleep because that can impact on my results. Which here, can you think of something with weak positive correlation? Remember, positive correlation moves together. Okay? I increase how many hours I study, then what happens? My results increase also. Let's look at that now. So a negative, strong negative correlation looks like that. The points lie close to the straight line with a negative gradient. Remember, a negative gradient, it's a slope. So if you draw a line, that's what we get. So a negative correlation, points lie close to a straight line with a negative gradient. What is a negative? What is different? What does a negative correlation mean? It goes down together. Are we together? I don't study anymore. I reduce the hours I spend on my maths. My results goes down. The oil price goes down. The petrol price goes down. Are we together? The negative correlation? Are we together? Okay, great. So, what about a weak negative correlation? The points are more scattered but follow a general downwards trend. So there's a negative weak correlation. We can see we have a straight line there. The points, those are some of the points, okay? Negative, we can draw a straight line with a negative gradient, and the points are slightly closer to the straight line. Hence, we can conclude a weak negative correlation or association. Okay, fantastic. Now, what about no correlation at all? So no correlation, the points are scattered across the graph, indicating no relationship between the two variables. There's no relationship. Can I draw a line then? I cannot draw a line. Can you think of two variables with no correlation? It's like no association between them. Can you think of any? Okay? I'm trying to think of something with no association between the two. Okay? So, how about, I can't think of any now. Okay, if something comes up, I'll come back. There's no relationship between the two variables. Okay? I mean, let's say if I eat bread every day, will I do well at maths? Is there a relationship between that? Okay? Maybe. But I don't think there's correlation between that. Okay? Okay? Good. So, there's no. So correlation is a measure of relationship, okay? But we spoke about the two variables, relationship meaning association. The stronger the correlation or the association, the more closely related the variables are likely to be, okay? The correlation coefficient, so we call this correlation coefficient, lies between -1 and 1. This can also be written as this. So this implies the correlation coefficient is between -1 and 1. What does this mean? We can quantify, we can measure correlation. And correlation is from -1 to +1. If correlation is 1, we say perfect correlation. If correlation is -1, it's a perfect negative correlation. Are we together? So because this is from -1 to 1. I mean, in between there we have what? 0. Are we together? I mean, 0.5 would be somewhere there. I mean, -0.5. Positive 0.5 there. So what does that mean? This is perfect correlation, which is 1, and this is negative perfect. No correlation there. So this is positive 0.5. So this is a weak, okay? And this is a weak positive, and this will be weak negative correlation, okay? Are we together? What about 0.1? 0.1 will be very weak positive correlation. Are we all together? So correlation can be measured, and the value is between -1 and 1. And at later stage, we'll look at how can we really calculate this correlation and get a number. And from there, we can make some conclusion. Okay, let's look what we have now. So we agree that correlation is between -1 and 1. This implies, just using inequalities, correlation is between -1 and 1. What does that mean? If someone says, my correlation is 2, oh, that does not make sense. Because correlation is between -1 and 1. If someone comes and says correlation is 0.5, yes. Correlation 0.5. 0.5, it's between -1 and 1. Are we together? It cannot be something bigger than 1 or something smaller than -2. It's impossible. It's between -1 and 1. That's correlation. So what do we say? We say if R is 1, R is 1, it implies this indicates a perfect positive linear correlation, association. I'm able to draw a perfect straight line. If I do that, that's a perfect association. Are we together? So those two variables are, we're 100% sure that they are strongly associated. if R is equals to 1. Okay? Positive linear correlation. What about -1? So -1 also, you can see that our point's going down, but we can draw a straight line going through all the points on our scatter plot. So that's a perfect negative correlation. Are we together? One goes up, one goes down. Okay? Positive correlation, going up. Together. Are we together? And zero correlation is quite difficult to draw a line of best fit. I can't draw a best line of fit. One can say, okay, there, okay, but that's not really perfect. Okay. Are we all together? So now, what do we say? Positive correlation. Two variables moves together. One goes up, the other goes up. Negative correlation, one goes up, the other goes down. Zero correlation, no association. Yes, we're interested in two variables that have no association. We also want variables that something goes up, something goes down. We spoke about what is that? Inflation. If inflation goes up, I cannot spend more money. My money in my pocket goes down. But positive correlation, one goes up and one goes up also. Okay, fantastic guys. I hope this makes sense. And we'll come back, see you after the break and look at more statistics. And remember to keep working hard and pushing hard. What is most important with your mathematics or anything is consistency. Consistency is the ability to study every day. If you say, every Tuesday I'm doing this, you wake up and do it, even when conditions are difficult. That's consistency. That's how you get better. Consistency is very important. See you after the break with more statistics.